Well, our next presentation is going to be from a couple of heavyweights. We've got Bruce Jameson and Scott Thumlert. And although it's been a while, we here in Fernie, we actually like to claim Bruce Jameson as one of our own. He was a ski patroller here back in 1980 and cut his teeth in the ski area's fledgling avalanche control program. I don't know if you can see it, but it's right back there. We couldn't quite hold on to him though, and he became a professor with the University of Calgary. And from 97 to 2015, he managed the Applied Snow and Avalanche Research Program there. Though he's steeped in the field of research, Bruce has never forgotten his practitioner roots, and he's the very embodiment of the ISSW's theme of merging theory and practice. And we're really lucky that Bruce continues to work as an avalanche consultant and educator. Now, Scott has also worked hard to strike that exceptional balance of both field and analytical experience when it comes to avalanches. After graduating under Bruce with his PhD in civil engineering, specializing in avalanche mechanics from the University of Calgary, Scott also worked as a postdoctoral fellow with our previous presenter Pascal at Simon Fraser University. These days he works as an avalanche consultant and is an ACMG ski guide. And to satisfy that very Canadian love for powder, he also heli ski guides with Canadian Mountain Holidays. I'm excited to learn about their new ideas for communicating likelihood and probability of snow avalanches. So over to you, Bruce and Scott.
Okay, all right, thanks, Jennifer. In 2019, Scott, Grant, and I wrote an article on avalanche likelihood for the Avalanche Journal and the Avalanche Review. After that article was published, we received a really encouraging amount of thoughtful discussion, probably more than any other article I've written before. And so this presentation builds on that discussion and on Scott's survey of the probabilities associated with likelihood ratings. So let's roll with the discussion, roll with the video of our presentation.
Avalanche likelihood is one of the key things that avalanche practitioners need to clearly communicate to each other. In this presentation, Scott Thumlert, Grant Statham, and I explore some ideas on how to communicate avalanche likelihood and probability more consistently. But these are just ideas in an evolving subject. We'll finish with some discussion points that need your input. To put avalanche likelihood in context, here is the framework for the conceptual model of avalanche hazard by Grant Statham and colleagues. This model is widely used in North America. After selecting the type of avalanche problem, for example, loose wet or deep slab, location is defined as where in the terrain the problem can typically be found. The forecast team then combines the sensitivity to triggers, which has 4 levels, and the spatial distribution, which has 3 levels, to get the avalanche likelihood, which has 5 levels. Let's look at 2 examples of spatial distribution. Assuming the specified location is alpine, this photo shows widespread avalanching, and this photo shows isolated avalanching. Clearly, the spatial distribution is part of avalanche likelihood.
Over the last 4 winter seasons guiding helicopter skiing in Canada, I had the opportunity to see how the conceptual model for avalanche hazard was working in the field. After a few discussions, call them arguments, with guides about the likelihood terms, we became interested in what other folks in the avalanche industry actually thought the likelihood words meant to them as percentages. So we asked avalanche practitioners from around the world, received 75 responses, for what they interpreted the likelihood words to mean about the chance of avalanches. What percentage comes to mind when you say likely? Here are the results. We see separate median values for each term, which is good. And these are also similar to what has been established in other industries. However, we see large ranges for each term and large overlap between terms. This could be problematic. How could one practitioner be thinking 10% for likely and one be thinking 85%? Here's some data from a broad survey about what percentages people associate with general likelihood terms. Our results generally match the broader population with perhaps even more overlap between terms. There are likely many reasons for this, and the most obvious one is that the avalanche industry has yet to explicitly define probabilities for these words, which means avalanche workers have yet to be trained in what probabilities to actually use. It is worth noting that possible is not on this list, and overall the literature shows that it's a poor choice for a likelihood term because it does not actually indicate probability and thus creates a bit of confusion.
In the conceptual model, likelihood is defined as the chance of an avalanche releasing within a specific location and time period, regardless of avalanche size. However, Scott has shown that there is considerable overlap in the interpretation of probability for the 5 classes of likelihood. One reason for the varying interpretations may be that different operations and different forecasters interpret specific location differently. Some practitioners forecast for a few paths. Others forecast for regions with many thousands of paths. Probability estimates, and hence likelihood ratings by forecasters, are likely influenced by the size of the area that they commonly forecast for. Highway operations expect and observe fewer human-triggered avalanches than some backcountry and ski area operations. So, the number of backcountry users within a forecast area may affect the likelihood ratings. These are a few of the reasons that the likelihood ratings may vary for the same conditions.
Okay, there's good news for us in the avalanche industry. Many other industries and disciplines have been working on the problem of how to effectively communicate probability. Many disciplines, such as climate scientists trying to communicate climate change to the public, intelligence agencies creating standards across their whole agency, and meteorologists using probability in weather forecasts. The following few slides are the Coles notes from about 50 papers exploring communicating probability. So we can communicate probability with words or likelihood terms, something like no chance, unlikely, fair chance, sometimes, possible, 50-50, likely, and many other similar terms. The advantages of words are they are very good for fast communication between people. So for example, maybe avalanche practitioners discussing avalanche events in the field. So what are the disadvantages of using words? As their survey showed and the literature and research has established, likelihood words are interpreted differently by different people. They're also interpreted differently by the same people in different contexts. So maybe on a different day or when the people are in different moods. Likelihood words are also susceptible to self-serving interpretations. And finally, people prefer to communicate opinions verbally with words, but they also prefer to receive precise numerical information. Okay, we can also communicate probability with numbers. Let's say 0 to 1. 0 being that the avalanche is definitely not happening, and 1 being that the avalanche is definitely happening. Percentages are commonly used for this. The advantages of numbers are they can be more precise. For example, the probability of rolling a 6 on a dice is 0.16666, and you can write as many sixes as you want to be as precise as you'd like to be. Numbers, you can also accurately reflect your uncertainty by giving a range. So for example, the probability of that 5-week-old surface water layer down about a meter waking up tomorrow, let's say is between about 5 and 60%. We're not very certain, and we can reflect that uncertainty with a range. What are the disadvantages of using numbers? First of all, they're slow. It takes time to understand, rationally interpret what the numbers mean, and then make a decision. Therefore, they're not that suitable for fast, intuitive decision-making of the kind that avalanche practitioners may be doing in the field. Another disadvantage is that often the reference class is not specified. We'll explain what the reference class is using this example, 20% probability of precipitation in Vancouver tomorrow. How many people out there have actually wondered what meteorologists mean when the forecast states 20% chance of rain tomorrow? Do they mean it will be raining on 20% of the area of Vancouver tomorrow? Do they mean it will be raining on 20% of the time tomorrow in Vancouver? Do they mean that for each point in Vancouver, there will be a 20% chance of measurable precipitation? Or do they mean it will rain on 20% of days that are similar to the forecast tomorrow? Probably some folks out there know the right answer and some don't. Area, time, points, and days are the reference class in each of these examples. So we add confusion when trying to communicate probability when that reference class is not explicitly stated and defined. We can also communicate probabilities as frequency statements or rates. A frequency statement is how many out of how many. For example, data are roughly showing that on average, about 2 out of 100 people who get COVID-19 will be killed, or about 1 in 4,000 people who live in Canada have died from COVID. So people with COVID or people who live in Canada are the reference class for those rates. The advantages of frequency statements are that research has shown that people are better at interpreting and understanding these, especially for small probabilities. So what is easier for you to interpret? A probability of 0.00025 or the same probability written as a rate of 1 in 4,000? Also, for frequency statements, the reference class must be defined. So here is that same 20% chance of precipitation written as frequencies. Note the reference classes in each of these examples are defined. What are the disadvantages of frequency statements? Again, frequencies are slow, as with numbers, are slow and therefore may be difficult for fast, intuitive decision making. Also, they're perhaps difficult for single event probabilities. What is the frequency of that avalanche path releasing tomorrow? To summarize, there's a depth of research across many industries that has established that communication improves when likelihood words are explicitly defined as probabilities, the reference class is defined and stated, and the probabilities are in the intuitive range for what most people would associate with those words. Another important point for these probabilities and ranges is that they should be defined by the user group. So for the avalanche industry, we can and should define our own probability ranges that are useful for decision making in avalanche terrain. A good communication system for probabilities would allow the use of words or probabilities or frequency statements. The words would imply the probability ranges and the frequencies, and then these would be consistent across all people in the industry. To reiterate, these concepts have been shown to improve communication across many industries and disciplines.
Summarizing Scott's points, here are some things we should look for in an improved likelihood scale. The scale should be based on a relevant reference class that is independent of spatial scale. For each level of the scale, the likelihood terms should be associated with probabilities and frequency descriptions. The numerical probability ranges should be useful for making decisions regarding avalanche terrain. The terms and probabilities should be intuitive and consistent with well-established ranges. And here is an optional attribute for discussion. Should the frequency descriptions facilitate validation, that is, checking against the number of observed avalanches? Here is our proposed definition of avalanche likelihood. Consider the avalanche paths or start zones in the forecast area, where the specified avalanche problem type is expected to exist. The likelihood of avalanches is the chance of those avalanche paths or start zones releasing within the forecast time period, regardless of avalanche size. For discussion, we propose this scale that satisfies the attributes in the previous slide. To be useful for decisions regarding avalanche terrain, there are 4 levels. Likely is for when many slopes are expected to release avalanches. This term captures the uncertain middle range. This term is for when the problem is on the radar but unlikely. And this term is for low probability, avalanche problems we don't expect but cannot disregard. The scale is based on the reference class, which is the practitioner imagining the terrain within the forecast area, where the forecaster expects the problem type to exist. The practitioner then estimates how many of the 100 paths or start zones are expected to release avalanches of the specified problem type. The corresponding probabilities range from less than 1% to more than 30%. The frequency descriptions are not very useful for in forecasting for a single path or an area with a few paths. In this situation, the forecaster should use the probability ranges or likelihood terms. This scale is simply a basis for discussion to give you a target to swing at. To get the discussion started, here are some points Grant, Scott, and I have been rattling around and not always agreeing on. Is imagining avalanches expected in N of 100 paths or start zones practical for practitioners to visualize or estimate? Or should the reference class be temporal? For example, avalanches in a typical path or start zone on N of 100 days. The scale goes from less than 1% to more than 30%, which covers 2 or 2+ orders of magnitude. Should the scale span more orders of magnitude? Last year's ski cutting survey showed the frequency of ski cutting varied over roughly 4.5 orders of magnitude. However, asking that a practitioner estimate the number of expected avalanches over 10,000 or more paths is likely beyond intuition. Should there be more levels at the high end of the scale? For example, should the scale have classes for likely, very likely, and almost certain? Or should there be more levels at the low end to better characterize the low probability, high consequence situation? Should the frequency of human triggering be excluded from the frequency descriptions, since it depends on the skill of the people traveling in avalanche terrain, compaction, and the number of people in avalanche terrain? Or should the practitioner estimate that people will be center punching the avalanche start zones in the 100 paths? If we assume center punching, then the frequency descriptions cannot be validated. In Schweitzer's validation study, he used whichever natural avalanches and human-triggered avalanches were reported to the forecast center. Some countries are now counting avalanche deposits with satellite imagery, but that will not be affordable for many forecast areas in the near future. Since we don't agree on these points, we'd like your input to make this a better likelihood scale.
Video's over, guys.
Okay, guys, I hope that was the end of the video because it stopped playing for us. Bruce, you could turn your camera back on as well so we could see you. Did you have some closing statements before we open for questions?
So that the questions in the last slide, are they being shown now?
No.
Brent, Jennifer?
No, they are not. Your video is over.
They're not being shown, okay.
Folks, Bruce is just trying to share his screen. Oh, there we go. And I'll let Bruce take over again. Yes, Bruce.
Good, Bruce.
You can see the questions now? Okay, so yeah, let's open it up to questions. You can raise your hand, and then, and Grant, feel free to turn on your webcam and your mic and join in here because this is a 3-person project. And let's have some questions from the floor.
Do you have any questions in the queue yet, Brent?
We currently have no questions from the floor. I think people are, oh, just wait. Here we have one from Jordy Hendricks. Go ahead, Jordy.
Yeah, good morning. Fantastic presentation. Really enjoyed that. One question that I have for all of you is, and you touched on this, Bruce, is the fact that we, for backcountry advisories, regions do not observe all avalanches. And while there are some techniques out there to try and detect avalanches, from space using Sentinel-1 and various other approaches, it seems to me that to calibrate your probabilities as a forecaster, having some information about what actually did happen after a forecast would be really, really important. Could you just comment on the value of knowing the total extent of activity within your region and how that might help calibrate or improve your estimation of likelihood?
Do you want to take that one, Grant?
Sure, I'll give it a shot. Good question, Jordi, and I think it would be an enormous help to us calibrating. I mean, at the moment, we have so many gaps in our data. It's intermittent. You know, I work in Banff, Yoho and Kootenay National Park. We have a relatively large area, and we feel we have lots of data for our area. Lots of people out there skiing, InfoX reports, 3 ski areas, but still, we scratch the surface when it comes to how much avalanche activity really happened, and we don't really know. One of the things I liked a lot about Schweitzer's paper, if anyone hasn't read that yet, I would highly recommend reading it, how they did the validation study done with avalanche activity around Davos. I mean, that is ultimately where we need to go in the future. And so when the day comes when we can actually get real data, and I don't know if this will happen in my lifetime, but real data on the widespread nature or not of an avalanche cycle, I think it would be huge in helping us truly understand the probability and the likelihoods. But until that time, you know, we're estimating, and I think we will be until we have real data. And I think some of the questions Bruce has put forward here are good ones, trying to figure out the most, I guess, intuitive or natural way for a forecaster to try and estimate the avalanche activity. And the last part I would say on that is this, what I like about the structure of what's proposed here is that when validation data does appear, it can be presented in the same way in terms of frequency. So it can plug right into this and we'd already be speaking the same language. I hope that answers it okay.
Yeah, fantastic. Thank you.
Excellent. Do we have any more questions lined up with the hands up feature, Brent?
We have no questions from the floor currently, but it looks like there may be one in the chat box.
Okay, I'm going to pass it over to Olivia for one of the questions from our chat box.
Yeah, this question is coming from Jenny at Scott and Bruce. How do you determine the confidence range in the denominator of expected release of avalanches?
If this question is about the reference class, I think Scott's the best one to tackle that. That's the denominator of the frequency descriptions, or part of the, yeah, it's part of the frequency description. Scott?
Sure. If I can understand the question, so the confidence in the denominator, like, i.e., what denominator would be most useful? Is that the question is going?
I can read it again. Yeah, it sounds like, how do you determine the confidence range in the denominator of expected release of avalanches?
That's a tough question. I mean, certainly maybe what we just touched on with actually observing how much avalanche activity that we saw out there, and then calibrating yourself to be able to predict that maybe could reduce your uncertainty in those ranges. But I mean, I'm not totally sure what the question is getting at. I'm sorry.
Maybe after the session, Jenny will add some clarifying statements in the chat box and you guys could take a look there. Do you have, what's that? Brent?
Just so you know, we've unmuted you if you'd like to ask that question audibly here to maybe help the guys out with an answer.
Oh, yes, I apologize. I think I'm just kind of thinking probably what Susanna Whalen already described yesterday. With AADS system, you'll get a true sense of how often avalanches happen. And in short of having those surveillance systems in place, I'm just wondering, when you're talking about likelihood, how would you really know how many events are happening versus the likelihood of triggering the avalanche?
Okay, I got you totally. Yeah, so you're exactly right. We need to have some of that data coming in about how much and how many avalanches actually occur given a different likelihood forecast, and hopefully that some of the new technology that was discussed yesterday for the Bear Pass and some satellite technology that Bruce was mentioning. So those data eventually come, which would be great. So for right now, we are estimating. I think all forecasters are estimating and basing their forecasts on a bit of uncertain and imprecise data, and we just do the best we can. So with the four categories of what we're sort of throwing out here for discussion, we tried to think a little bit about what is and what could be useful for decision making in avalanche terrain. And so those four levels, just maybe just as a start, if you think about your operation and how you work with avalanches, those four levels just be useful. So a likely sort of that middle ground where maybe you just don't even know and you're just saying, yeah, there's a fair chance you might have wind slaps. And then one where you're getting out of that and you're moving into the unlikely stage. And then some way to better characterize that really low probability but high consequence event, and maybe a big size 4 avalanche coming down.
Yeah, so we're getting into the business of assessing likelihood, and that's a really challenging question that I think Grant has thought a lot about. But one part of that is that when at the higher levels of avalanche likelihood, we tend to have some data from the previous day or overnight or whatever through increasingly drones, satellites, and actual good old observations. But at the lower levels, when avalanches are unlikely, I think this is just a personal opinion, I think there's a role for snowpack tests because we don't have avalanches at the lower levels of avalanche likelihood. And what are we going to use? And I think of necessity, we have to use snowpack tests, which are, I don't know, flawed or limited. But I'll just throw that out there because that's a hot topic.
Good one, Bruce. I think we have one more question in the queue here. Brent?
Yes, we have a couple folks here. We're going to go with Tim Johnson. Go ahead, Tim.
Hey guys, Tim from Jasper here. I'm wondering if you have looked at the use of avalanche danger assessment matrices, where you've got sensitivity to trigger on one side, spatial distribution on the other side, both which have pretty solid definitions, and how that helps bring forecasters to kind of the same level in terms of likelihood.
You're nodding your head, Scott. Why don't you speak up?
Yeah, I mean, absolutely. I think Grant would echo that and state that it's super important to have those types of assessment methods that get as much consistency in the sort of forecasting teams as possible. So yeah, I think those are really great. And the ultimate maybe output of this likelihood scale and this work should mesh seamlessly with like the conceptual model of avalanche hazard and how those likelihoods terms are already assessed. I think that it's a great method. It works super well. And certainly when you have time, when you're in the morning meeting and you're doing maybe a forecast like that, you can use those assessment methods. And then maybe if you're in the field and actually maybe skiing or guiding or something like that, you're not really going to have time to use those types of processes. So, but it all should merge seamlessly. But maybe I would imagine Grant has something to say here too.
Is there time, Jenna? Yeah, I'm totally with you, Scott, and I think that's a really good question, Tim. I just want, maybe it would be helpful just to point out a little bit of history of likelihood terms. So when we first produced our early versions of the conceptual model, we didn't have a lot of structure around likelihood. You know, we brought it in off the danger scale, and you know, we used the word, let's just say, unlikely, and then we essentially just left it to forecasters to figure out what it meant. So very raw, basically. And I think that a lot of that is what led to those wide ranges that Scott picked up on the survey. When we eventually published the paper on the conceptual model, you'll notice a matrix just like Tim asked about there. You know, it's got sensitivity on one side and distribution on the other. They combine to give you a likelihood. So that is the way we do it where I work. We follow that, you know, to a T pretty much, and it's been incredibly helpful for helping us be consistent on likelihood. So I like it. But I think this step that is being proposed here takes us to the next level, which is to actually structure likelihood properly, or about how likelihood should really be used with frequency, with proper reference classes. So I think what we're doing here is the next step for the likelihood scale, and it would continue to make it consistent, but would bring it out of kind of the present matrix that we're using in the conceptual model.
Thanks, guys. Unfortunately, we're at the end of our session, and I know there's still questions in the queue. So at the end of this session, we'll keep the chat box open so you guys have a little bit more time to interact with the speakers there. I know I really look forward to trying out some of these new ideas this season with my team and seeing what we can come up with. Thank you to all of our speakers in the risk communication and rescue category today. And I'd also like to thank our session sponsor again, MND. And right now, I'm going to pass us over to James, our host, and he's going to wrap things up for this session.
Yeah, thank you very much indeed, Jennifer. And thanks again to all of the speakers from that last session. I would like to quickly acknowledge that there was an incorrect link on the presentation website taking you to that last session. It does appear as though most people did manage to join, but my apologies if you did have trouble joining in at the start of the session. Just to remind you that if you felt like you missed anything, have a look for those recorded session links and you should be able to catch up with anything that you missed out on. So we're going to take a half-an-hour break, and we're going to return at 10:30 Mountain Time for the panel discussion, which is entitled Finding Gold Dust, Mentorship in the Avalanche Industry. So please enjoy your break and tune back again at 10:30. Thanks very much.